let's take a look at how to find z-scores, which encompass a certain percentage of area on a normal curve. Let's use the example of finding z-scores for which 70% of the area would lie. So you're going to have two z-scores. You're going to have a negative z-score and a positive z-score. So let's just sketch a curve. Those of you that have me for class know that I'm not going to do any kind of a normal distribution problem without drawing a curve. So I've got a negative z-score and a positive z-score here. So I'm going to be looking for a negative value and I'm going to be looking for a positive value. And I want to know what scores are going to hold 70% right here. So I know this whole thing, let me change colors here for no other reason than just because I can. I know this whole thing right here is 100%. And I know that right here is 70%. So that tells me that in these tails, I must be taking up 30%. All right, because 30% and 70% makes 100%. So if I've got 30% in these tails, all total, just a little bit of arithmetic tells me I've got 15% in each tail, right? So we can do that in our head, right? 30 divided by 2 gives me 15. So we know that we have 15% in each tail. So what we want to do is figure out what z-score is going to mark off 15%. So let's take a look at the z-score table to see which one gives us that. Now I'm going to use the table that's the easiest to use. Either one will do it for me, but if I look at my picture, I want one that's going to give me this little bitty tail right here. So let's look and see which one's going to give me the little bitty tail. The positive z-score table that I use gives me this big cumulative area up to here, but the negative one will give me the negative side in this little itty bitty tail. So that's the one I'm going to use. So since I'm looking for the area, I'm given the cumulative area, I'm looking for 0.1500 here in the middle. And if I can't find 0.1500, I want to find the number closest to it. So I'm choosing between 0.1515 and 0.1492. And so I want the one that's closest to it. In order to determine which one is closest to it, I basically just subtract each one. If I can't tell right off the bat which one is closest, I subtract each one from 0.1500 and see which one is closer to it. And so this one is closer to 0.1500. So the z-score that I'm going to use is negative 1.04. So the z-score is going to be negative 1.04, and since it's an even split, it's going to be a positive 1.04 on this side. So those are my two z-scores that are going to encompass 70% of the data. Now, if you're lucky enough to have Minitab, let me just show you really quick how to do that in Minitab. We'll go into Minitab, under Graph, Probability Distribution Plot, View Probability, OK, Normal. We're using z-score, so we're mean of 0, standard deviation of 1, shaded area. We want to know the probability encompassed by two z-scores. Now, this key tells us right here we have the probability divided by 2, so we want to give it the whole probability that we know. We know 30%, we know 0.300, so we don't want to divide it by 2 for Minitab. We want to just let Minitab do that itself. So we're going to go ahead and tell it we know that it's 30% left over instead of the 0.1500. We're going to let Minitab do that. And we're going to click OK. And voila, there it is, negative 1.036, which we round to 1.04, and negative 1.04. So you can either do it manually with the table, or you can do it by hand. But notice how Minitab gives you that same beautiful curve that I sketched, which I think is pretty handy dandy. And you can check it, see how it's 0.15 and 0.15, which adds up to 0.3, and you've got 70% in the middle.